we're going to do grade 8, lesson 2, which is about numeric patterns. So, why is numeric patterns useful? Well, numeric patterns are found all in nature, and it's not a coincidence why it's so common. However, in grade 8, we're going to learn 3 types of patterns. There will be more patterns you might learn in all the grades. However, today we're going to learn 3 patterns, namely arithmetic patterns, as you can see here, geometric patterns, and other patterns. And I've ordered them in difficulty. Usually other patterns are quite tricky because there's no formula that you can follow. So, let's start with arithmetic patterns. Well, firstly we need to know what is an arithmetic pattern. Well, let's start with an example. Consider this pattern here. We have 1, 3, 5, 7, 9, 11, and so on. Now, as you can see here, when you jump from 1 to 3, you add 2. When you jump from 3 to 5, you add 2. 5 to 7, you add 2. 7 to 9, you add 2. 9 to 11, you add 2. So each time you're adding 2 to get to the next term. And so, as you can see, arithmetic patterns will always have a common difference. And well, what is a common difference? Well, we have here, a common difference is D, and that is the difference between 2 adjacent terms, or 2 terms that are next to each other. For example, 3 minus 1, 5 minus 3, 7 minus 5, 9 minus 7. They all have a common difference of 2. Now, if you spot an arithmetic pattern, you can always use the general formula, as you can see in the top right. The general formula is Tn equals A plus n minus 1 times D. Now, if we break up this general formula, it seems there's a lot of variables. Well, A is just the first term. So, in this pattern here, A would equal 1. N is the position of the term you want to find. So, let's say you want to find the 10th term, then N will be 10 in the formula. And Tn is the term, so N is the position of the term, Tn is the term you want to find. So T of 10, you want to find T of 10, then you substitute N equals 10. So T of 10 is like your output, what you're solving for. And lastly, D is the common difference. And yeah, so D is the common difference. So in this case, in this pattern here, D equals 2. Okay, so as you can see here, each time you're plussing 2. That means that your common difference is 2. And you can add 2 each time. So how do we work out this formula? Well, we will say T of n. Usually in numeric patterns, we want to find the general formula because then we can find any term. We can find 100th term, the 1000th term, any term we can find if we find the general formula. So T of n equals A plus n minus 1d. I recommend you always write down the formula as your first line. So A plus n minus 1 times d. So now A equals 1, right? So A equals 1 in this case, because A is the first term. So 1 plus n minus 1, okay? We're trying to find the general formula. So when we find the general formula, we leave n as it is, because n could be anything we want. Now D. D is what we find here. We're plussing 2 each time, okay? So D can be positive or negative, but in this case it's positive because we're adding 2 each time. So we're timesing by 2, okay? So that's equal 1 plus. Now, to do this, we can use what I call the Dolphin Method. The 2 has to go to the n and to the minus 1. So, if you simplify this, it will be 2n minus 2. Okay? The 2 goes to the n and to the minus 1. Now, if we simplify this, we get 2n minus 1. Okay, so therefore Tn equals 2n minus 1. So that's our general formula. So therefore, if we have Tn equals 2n minus 1, that's actually really helpful for, they usually have quite a few questions. They have an A, B, C, D, and so forth. So then if you find a general formula, it will help you a lot to find the next questions. For example, if you want to find the 100th term, you just say 2 over 100 equals 2 times 100 minus 1, which would be 199. But this formula, you can just say, okay, this formula is helpful, but what is this formula? How do you actually get this formula? Well, let's consider an arbitrary, a random arithmetic pattern. Our first term is going to be A, because A is the first term, right? What's our second term going to be? Our second term is going to be A, first term, plus D. Okay, because we have that, we add D, because that's our common difference, right? So that's our first term, our second term. Our third term will be A plus 2D, because we're going to add D from the second term. So it'll be A plus D, which is A plus 2D. And as you can see, a pattern might emerge, and we can do it up till, let's consider the 100th term. The 100th term will be A plus 99D. Okay, and that's because we will be adding D 99 times. So we are adding D all the time until we get to the 100th term. And as you can see, the 100th term will be one less. That's why you get the n minus 1, A plus n minus 1. And that's the formula. That formula is very helpful. So let's try to see what a question will look like in an exam. So if a question goes like this, they usually give you a diagram. And the diagram will have houses. This question has houses, right? So the first step is we need to try to convert this to numbers. Okay, so let's first try to convert these to numbers. Well, our first one will have how many matchsticks, right? Because these are made of matches. So our first one, which I'm going to call T1, okay, because Tn is the nth term. So the first term is 1, 2, 3, 4, 5, 6. So 6 matches. Okay, our second term will be 6 plus we have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So 6 plus 5, so that will be 11. And our third term will be, so we will still have 11 from here, and we add 1, 2, 3, 4, 5. So it will be 11 plus 5, which is 16. Okay, so that's our first step. We're trying to look for the numbers. Now we have to see, do we have a common difference? Well, to get from T1 to T2, we have to add 5. To get from T2 to T3, we also have to add 5. So as you can see, we're adding 5 each time, so we have a common difference. And that means we have an arithmetic pattern. So, what does this mean? Well, this means that we can get the general formula. General formula equals Tn, which equals to A plus n minus 1 times D. Okay, which equals to, what is our first term? Our first term is 6. And our common difference, as we said, is 5. So it equals to 6 plus n minus 1 times 5. As you can see, we're going to use the dolphin again with the 5. So 5 goes into n, 5 goes into 1. And you get 6 plus 5n minus 5, which equals to 6 plus 5n minus 5. Okay? So as you can see, the formula will turn out to be Tn equals 5n plus 1. Cool. So we found the general term. Okay, Tn equals 5n plus 1. And you can even check it, right? So when you get the general formula, you should always check your answer with the terms that they give you. Okay, so what I mean by this is that, let's try to find T1 again. T1 equals 5 times 1, because n equals 1, plus 1, which equals to 6. And we know that T1 equals 6 here, right? That's 11, and that's 16. And you can do it for n equals 2 and 3. And if you get all the answers the same, that means that you're doing a good job. Okay, so now let's look at the second question. Second question, find the 10th term. Okay, so once you get the general, that's why you get the general formula. So once you get the general formula, to find the 10th term, you say T10 equals, substitute that n equals 10 into the general formula. So we 5 times 10 plus 1. Okay, which equals to 51. So the answer here is 51. 51, this 51 matches in the 10th when you do this all the way up to 10. Okay, so now the third question. Well, the third question seems a bit weird how it is phrased. It says, which term has 506 matches? Okay, so now we actually have to find which term has this amount of matches. Well, what does it mean if something has matches? Well, this term Tn, that's the number of matches, right? This is number of matches, because that's our output. Okay, so now they actually give you the answer. They give you the output. So when you have Tn equals 5n plus 1, okay, again, we're using the general formula. Tn equals 5n plus 1, which term has 506 matches? Well, our output is 506. So we say 506 equals 5n plus 1. And now we're actually solving for n. Okay, so this is like an algebra equation. And how do we solve for n? Well, plus 1, take the other side, so you get 505 equals 5n. And now you just divide by 5 both sides, so you get 101 equals to n. Okay, so as you can see here, that's our answer. N equals 101. So the 101st term. Okay, and that's how you do arithmetic patterns. The general formula is very important, so I would recommend you learn this formula. Now the next type of pattern is geometric patterns. Again, geometric patterns is a bit more trickier. However, it also has the formula like arithmetic patterns. So if you understand how to use the formula in arithmetic patterns, geometric patterns, you just need to learn the second formula as well. So what is a geometric pattern? Well, a geometric pattern has R. Okay, R is the new thing we have, and R is called the common ratio. Okay, so as you can see, we have example 3, 6, 12, 24, 48. Now the common ratio is how do you get from 3 to 6? We're not going to add 3, we're going to times by 2. Okay, that's the common ratio. What you have to times this term, first term to get the second term. What you have to multiply the second term to get the third term? Well, again, we have to multiply by 2. Okay, the third to the fourth term, multiply by 2. And the fourth to the first term, multiply by 2. As you can see, we keep on multiplying by 2. Two adjacent terms, we keep multiplying by 2. And that's going to be a common ratio. Common means equal. So the ratio between the two adjacent terms is always equal. Now, as you can see in this pattern, we want to find, as you can see, the general formula here we have. So Tn equals A times R to the power of n minus 1. Again, n is like the term we want to find, like the 10th term or something. A is again the same as the arithmetic pattern. A is the first term. Okay. R is the common ratio, which I just explained. So example, R could be 2. Now, important is R could be 2. What if you work backwards? What if you go from 6 to 3? Well, if you go from 6 to 3, you have to multiply by half, which is the same as dividing by 2, but the common ratio is multiply. So you multiply by half. So R could be half. So R is usually like 2, 3, 4, but it can also be 1 over 2, 1 over 3, 1 over 4. Okay? But for this pattern here, we have R equals 2. So let's find the general formula. So I always write down the formula on the first line so that I know what to substitute. So Tn equals A times R to the power n minus 1. What is A? A is 3. 3 is our first term. What is R? R is 2. Now, you should always put brackets because you're only putting 2 to the power of n minus 1. Okay? So Tn equals 3 times 2 to the power of n minus 1. You don't have to put the brackets in, but I just do it so that it's easy to see that it's only the 2, not the 3. That's to the power of n minus 1. Okay, and that will be our general formula. So we can check our answer. If we say n equals 1, we get 3 times 2 to the power. So if we say T1, 3 times 2 to the power of 0. And we know 2 to the power of 0 is 1 from our previous lesson. So we have 3. And you can check it from the first, second, third, fourth, and fifth. And they will all give you the correct answer. So now, let's look at the second question. The second question says, find the seventh term. Again, this is very straightforward. We're going to just use our general formula. Tn equals 3 times 2 to the power n minus 1. So we get T7, because we're looking at the seventh term, equals to 3 times 2 to the power of 7 minus 1. Okay, so it's n minus 1, so 7 minus 1. Which equals 3 times 2 to the power 6. Okay, 3 times 2 to the power 6, and 2 to the power 6 is 64. Okay, you can use a calculator or you can work it out yourself. And you should get the answer is 192. That's T7. Okay. So now the third question. Which term has a value of 3072? Now, this again is something that we're going to work backwards. They are giving us that the value of the term is 3072, which is Tn. Okay, so they're giving us that 3072 will equal Tn. Tn equals 3072. Okay, which again means that we write down our general formula. So from question 1, our general formula is 3 times 2 to the power n minus 1. Okay, so 3072 equals 3 times 2 to the power n minus 1. So you divide by 3 both sides, you get 1024 equals 2 to the power n minus 1. Okay, now this might seem a bit hard, but what you're going to do is you're going to write 1024 in its prime factorization. So that means that 2 to the power of 10, which is its prime factorization, equals 2 to the power n minus 1. Okay, so as you can see here, both in the equation, if both have the same base, then the exponents have to be equal. So the 10 has to be equal to the n minus 1. So we can make them equal. We get 10 equals n minus 1. Okay, so n equals 11. So that means that the 11th term has a value of 3072. In other words, T of 11 equals 3072. And that is geometric patterns. Again, using that formula might be a bit tricky with the equations and the exponents, so make sure that you check your answer, not making any mistakes with the exponents. So now this is the hardest type pattern, other patterns. The reason it's so hard is because we don't know the formula yet. Okay, so let's consider this pattern here: 1, 4, 9, 16, and 25. So now you think, well, we need to do something with 1. If this is our n, right? This is our n, and that's our tn. Okay, our input and our output. So if n equals 1, the output tn is the first term is 1. If n equals 2, the second term is 4. N equals 3, the third term is 9. N equals 4, the fourth term is 16. And if n equals 5, the fifth term is 25. So now, as you can see here, you might be thinking 1 is 1 squared. 4 is 2 squared. 2 times 2. 9 is 3 squared, or 3 times 3. 16 is 4 squared. And 25 is 5 squared. So, as you can see here, Tn will equal to n squared. And that's our general formula. And if we have a general formula, that makes our life a lot easier in solving questions. Next question is a Fibonacci sequence. Now this is a bit of a high order question, but it is interesting to see these type of patterns because sometimes they could come up, you never know. So as you see, 1, 1, 2, 3, 5, and 8. Okay. Well, the common difference here will be 0. Common difference will be 1. Common difference would be 1. Common difference will be 2. It doesn't seem that there's a common difference, right? So maybe there's a common ratio. So now we look at the common ratio. Times by 1, times by 2. Yeah, it's not really a common ratio. Okay, so the first thing you must always do is check, is this an arithmetic or a geometric pattern? As you can see in the top one, there wasn't any common difference or common ratio. So for this, it's called the Fibonacci sequence, as you can tell by here. And the pattern is actually, if you notice, 2 equals to 1 plus 1. 3 equals 2 plus 1. 5 equals to 3 plus 2. And 8 equals to 5 plus 3. So as you can see here, whenever we have a term, for instance 8, that equals to this term 5 plus this term 3. 5 is equal to this term 3 plus 2. So it's always the nth term is equal to the sum of the two previous terms. So how do we write this? We say Tn equals to Tn minus 1. So Tn minus 1. So whatever that's the previous term. Plus Tn minus 2. So that's the sum of the two previous terms. Okay. 2 equals 1 plus 1. 3 equals 2 plus 1. 5 equals 3 plus 2. And 8 equals 5 plus 3. If you haven't understood how I got this, don't worry. This is just so you can be exposed to all types of sequences. But this leads me to our next slide. Plan to solve patterns. So firstly, our first step will be to change the diagrams to numbers. Okay. As you can see with our arithmetic patterns, we changed the houses to numbers. We changed our first house had how many matches. Our second house had how many matches. Okay, that's our first step, because usually they give you diagrams of matches or squares or circles, whatever it may be. Our second step, first check if the pattern is arithmetic or geometric. How do you do that? Well, to check if it's arithmetic, you look at the common difference, which means that you check the difference between two consecutive terms or two adjacent terms. If they're equal, it means it's arithmetic. Also, you can check the ratio. So, is there a common ratio? Do you multiply the first to get the second? What do you multiply the second to get to the third? And so on. If it's a common ratio, it means it's geometric. And that means our third step is, if we get that it's arithmetic or geometric, we can use the formula to find the general term. Okay, unfortunately, if we don't find it arithmetic or geometric, we can't use the formula, so we have to kind of guess the formula. Okay, but if we do get the formula, that's very nice, because then you can find the general term, and that's in terms of n. Now question 4 is actually answering the questions. Usually the question they ask for the 10th term, the 11th term, the 12th term. That means you just plug in n equals whatever 12, n equals 11 into the general formula. Another type of question they could ask, which term equals to something? Okay, so which term equals to 1,000? And you have to say, you have to work backwards. So you say the answer is 1,000. 1,000 equals to the general formula, whatever the general formula is. 5n plus 1, 3 times 2 to the power of n plus 1. And you work backwards and you try to find what n is. And that is pretty much the plan, our game plan, solving patterns. So our next slide, we're going to have some practice problems so you can consolidate what we've learned in this lesson. So as you can see, each question I asked for the general term or formula and the 12th term. And there is 3 patterns you can work with. And this should cover all the patterns we've learned today. Now the answers will be in the comment section, but if you don't understand how to get the answers, please leave a comment. And that leaves us to the end of our lesson. So please leave a comment if you have any questions, and like and subscribe if you like this channel.